All right, this video is just a continuation of the last video on this objective. I stopped the last video accidentally after I calculated the test statistic, but we had to finish the whole test. So this is just a continuation, part 2 of the last video. Alright, so we were here calculating the test statistic was 3.8 for this example, right? This was the example where you had the transportation, modes of transportation for Democrats and Republicans, and we were testing whether or not the transportation distribution for Democrats was the same as the transportation distribution for Republicans. Alright, so we had the hypotheses, found our test statistic. Great. And I showed you how to do some stuff in the calculator as well, and I'll get back to that later. Alright, so now we continue. And now they're asking us to determine a critical value for this test. Okay, so this is the same paper I had up last time. Again, I apologize for cutting that video too short. Found the test statistic, chi-square was 3.8. Now for the critical values. Now, in order to determine that, we need to know how many degrees of freedom, right, df, are there going to be for this chi-square distribution we're going to look at. Now, if you recall, this is going to be the same as for the independence tests, right, for the homogeneity test here. Look at my contingency table, right, there were 2 rows, 3 columns. And remember, the number of degrees of freedom for our chi-square distribution was the number of rows minus 1 multiplied by the number of columns minus 1. So that would be 2 minus 1 multiplied by 3 minus 1, which is just 1 times 2, or 2. 2 degrees of freedom. Alright, so we're looking at a chi-square distribution with 2 degrees of freedom. And I'll draw a little picture of this. So the number line here represents different values of chi-squared. Starts at 0, right? There are no negative values of chi-squared. And then with 2 degrees of freedom, it looks something like this. As a falling like this, and maybe even start like that, a little peak, but it was definitely bulky on the left and thin on the right, right? Skewed right. The mean was to the right of the highest peak. The mean was the number of degrees of freedom, has a mean value of 2. And the standard deviation would be the square root of 4, right, or 2 as well. Right, it was the square root of 2 times the number of degrees of freedom. But anyway, there's a very rough graph of our chi-square distribution with 2 degrees of freedom. And as we're seeing up here, again, this is a continuation of the last video, the level of significance was 1%, 0.01. And these are always right-tailed tests, these chi-squared tests for homogeneity as well as for independence. So what we're looking for is what chi-squared value has an area to the right of it under this curve of 1% of alpha. So what we're looking for is this, what's the chi-squared value with an area of 0.01 to the right of it. And that's where this table comes in. Right? So again, 2 degrees of freedom. So I'm in this row with the 2 degrees of freedom. And we're looking for the chi-squared value with 0.01 as a subscript, the area 1% to the right. So that's this value here, 9.210. That's our critical value. Alright, so this is 9.210. And that's what I'll enter in a second. But then, for this critical, so this is the rejection region, right, where we would reject the null hypothesis. Now, as was found in the last video, right, the test statistic was 3.8, chi-squared equals 3.8. Well, where is that? That's here in comparison to 9.210. 3.8. Right, there's our test statistic, which is definitely not in the rejection region. So we would fail. We would fail to reject the null hypothesis. All right? And then if we go back and look at the hypotheses, now the hypotheses, remember, are the same for all these homogeneity tests. the null hypothesis will be that the distributions for the transportation distributions for the Democrats is the same as for the Republicans. We are not rejecting that. We're keeping that. And if we're keeping that, we're not rejecting that, that means we're not supporting the other statement, that the distributions aren't the same. So we're saying that they're not the same, right? Or that they are the same. We have enough evidence here to say that they are the same. Okay, or we don't have enough evidence to say they're not the same. However you want to say that. Right? Okay, so that was the critical value approach. Back here, what's the critical value? 9.210. Wonderful. And again, you need to know your degrees of freedom and the value of alpha for that one. And then finally, the decisions. I already told you, because our test statistic is not beyond the critical value, it's not in the rejection region, we do not reject the null hypothesis. And if we don't reject the null, that means we aren't supporting the alternative. So at the 1% significance level, there's not enough evidence to conclude the distributions are not the same, right? There's not enough evidence for this alternative statement. So I'm clicking that one. Okay. And as before, with most of the objectives where you have to complete the steps of a hypothesis test, if you go through a test slowly and surely and get everything right, it's probably going to be the only problem you'll have to do for that objective. So it's pretty nice. All right. Now, as I brought this up on a calculator before. This is from previous. Remember, you can enter a matrix. Remember, let me go my paper. Remember, you can enter a matrix, a 2-row, 3-column matrix, again, as I did in the first video for this problem. And, enter these observed values, and then you go to the stat, hit stat, go to tests, go down to C where it says chi-squared test. I just hit alpha C. And chi-squared test come up. It asks you for, what's your observed matrix? Well, that was matrix A here. And then you don't have to worry about the expected matrix. As long as it's a different letter, it'll calculate it automatically for you. Then I hit calculate, and you see the test statistic comes up 3.8. The p-value. Now, if you recall the p-value approach, right? This is a right-tailed test. The p-value would be this area to the right of the test statistic. So the p-value, which is, this is given to us by the calculator. This is 0.1485. And this is definitely bigger than alpha. It's bigger. That's 14%. That's bigger than 1%. And if this is the case, right, if the p-value is greater than alpha, then you don't reject the null hypothesis. You fail to reject the null, which I already said earlier, we're using the rejection region. And you see degrees of freedom is 2 and all that, as we said earlier. But yeah, so you could also just enter your observed values into a matrix and run this chi-squared test and see the p-value, right? And compare the p-value to alpha to determine whether or not you'll reject homogeneity or not, right? Reject the null hypothesis or not. Okay, so just wanted to point that out as well. All right, and that's it. That's it for this problem. Again, I apologize. I cut off the first video right after the test statistic. I didn't mean to do that. I just lost my train of thought and forgot what kind of a problem I was running. I had to finish the test. So hopefully you watch both parts, and hopefully watching all this, both parts of this video, and looking at the more instruction when you need to, reading the answer explanations when they show up. I'm hoping all this stuff helps you when you're running through this kind of a problem on your own. Thank you very much for watching.